Hi, everyone. Welcome back to week 4. I'm sorry I'm a couple days late. It was the holiday weekend of 4th of July, and I just had gotten back from Yellowstone National Park, and I was tired and traveling to Austin and back really fast after I got home. So I was sure to start this right when my bunny was being quiet, but she appears to be ramping up, so we'll see what happens. So anyway, in this week 4, we're going to review all the linear things, not all of them, but most of the things that you need to know about linear functions and linear equations as we go into Algebra 2 pre-AP. We don't really spend a lot of time reviewing linear functions. You did so much of that in Algebra 1, and we don't use linear that much, but we do use it enough that we feel like you need an overview. So the things that you need to remember about linear functions, you need to be able to find the slope of a line. You need to be able to find the equation of something that you know is linear, either from a graph, a table, or a word problem. You need to know that the most common form of a linear equation or function is the slope-intercept form, that y equals mx plus b. I have important things down here that I know you're going to need to know, so you do need to know this form. You need to know the slope formula. There's two other forms of lines. One's called point slope form, when you have a point and a slope. That is a great one to use. And then standard form, which is when the x and the y's are on the same side, and you just have a constant on the other side, and you may have different coefficients in front of x and in front of y. We do have special case lines, horizontal and vertical lines, that don't use the slope-intercept or point slope form or linear standard form. We'll see that. The vertical line equation has a vertical line always has an undefined slope, and you just use x equals, and then whatever the x coordinate is of a point that you were given on that vertical line, or where you see that vertical line crossing the x-axis at that value, that would be the number that you would put in the equation. It's just a letter and a number with an equal sign in between. Same thing with horizontal. Horizontal lines have a slope of 0. There's an actual numerical slope, it's 0, and you use y equals, and you use the y coordinate of the point that you were given, or if you have a graph, you look for where that horizontal line is crossing the y-axis. At that value, that's the number that you would put in the equation. If you're given a word problem that is linear, something with a constant rate of change or a slope, you should be able to create a table of values from that. Any form of a linear equation that you're given, you should be able to change to a different form. Slope-intercept into standard form, point slope into slope-intercept form. And then also we will touch on linear inequalities. Remember, an inequality is something that doesn't use an equal sign. It uses a less than or a greater than. You still graph it like you do a normal line, but you have to make a decision on whether to connect the dots with a dashed line, which would be when you use less than or greater than, or if you're using less than or equal to, greater than or equal to, that would be a solid line. Anything with an equal to component to it will be solid. And then you have to decide where to shade. If you have a less than, either type of less than, you're going to shade below. If you have a greater than, any type of greater than, you're going to shade above. Remember, you can always do more problems than what I assign on Delta Math. You don't have to move on if you feel like you want more practice. You can always do more. And don't forget, you can look at examples or example videos for most problems on Delta Math. So if I haven't already said that, I'm sorry I've waited this long to tell you that if you're not familiar with Delta Math. So I've gone over all of these things on the front page. Now we're just ready to put those into practice. So these are the types of problems that you're going to be given. You may be asked to write a linear equation from a table of values. So you have some x's and you have some y's. So it's asking for slope-intercept form. So you need to find the slope, and you also need to find the y-intercept. Sometimes the y-intercept is very clear in a table. It would be a point that starts with a 0. This does not have one of those. So we're going to have to use the y-intercept. We're going to have to use the slope to help us find the y-intercept. Use slope if not already given. Remember, a y-intercept is a starting value when x equals 0. So that would be kind of right in between those 2 points is where that would be, and we don't know what that value is. So let's find the slope using 2 points. you can use the actual formal formula, or you can just pick 2 points and be like, okay, how did the y's change? Well, these got smaller by 20. It went from -5 to -25. That's a difference of losing 20. The x's changed by adding 4. So my slope is the change in the y over the change in the x, and that reduces to -5. Now, if I want to find the y-intercept, I'm going to have to use slope-intercept form. I have a slope, I have an x and a y, I have several, just pick one, and I'm looking for the b. So I'm going to take the y coordinate of the point that I've chosen, the slope that I've found, the x coordinate of the point that I've chosen, and we are just looking for b. So I'm going to add 10 to both sides, and that gets me the b, or the y-intercept value, is a +5. So my equation in slope-intercept form would look like this. There's the slope, there's the y-intercept. All right. Again, you don't have to do the y-intercept work if you've been given a point that starts with a 0. We just weren't, so we had to do that little bit of extra work. Okay, now if we're given a graph, or 2 points on a graph, we, on Delta Math, they want you to practice finding the rise and finding the run. So you would need to identify 2 points, and I'm just going to give you some, 1, 6 and 9, 1. And if you noticed, you would see the grid lines. We barely see them in this printout, but on the actual homework, you would see the grid lines. And you would just be clicking from one point to the other, vertically connecting them, and then horizontally connecting them and counting the slope. What was the rise? I went up 5, and I ran to the left, which is a negative movement. I ran to the left 8. So up 5 over 8 this way. That's a negative slope. So one of these two should be negative. And so when we put that in rise over run form, that gives us a -5/8 slope. So that is what you would be typing right down here. And remember, you can use a backslash and it'll give you a fraction. Okay, what if you just have 2 points? Well, remember, we have a slope formula that says that we can take the change in the y's over the change in the x's. And it's always a difference. We're finding the change as a difference. So I'm going to type in, I'm going to write the second y coordinate minus the first y coordinate, the second x coordinate minus the first x coordinate. And so minus a negative is a plus. So -13 plus 10 is -3, and 3 minus 6 is -3. And so when I reduce this, I end up getting a slope of 1. If you had gotten anything with a 0 on bottom, you would have chosen undefined. That button is just there in case you need that function, in case you need that answer. Otherwise, you're going to type your answer right here. It doesn't have to be a fraction if it can be reduced. All right, we're done with the first page. Now we're going to move on to vertical and horizontal lines. Yes. So vertical and horizontal lines. Remember, on the first page, I gave you an example that a vertical line always starts with x equals. So if I see an equation that starts with x equals, I know this is a vertical line. I would choose the vertical option here. It'll have a choice of vertical and horizontal. And then it's when you choose vertical, it's going to pop up with a vertical line right through the y-axis. You're just going to drag the dot that it shows over to the right location. We're trying to go to a x-axis location to the x-axis at what value? -4. And I've already done that in this picture. I'm showing you what your answer should look like here. You would have to drag it over to whatever location. So if it was a positive x value, you'd be dragging it to the right. And if it was a negative x value, you'd be dragging it to the left. And conversely, you could be given a problem where the actual line, vertical or horizontal, is already graphed and you're writing the equation. So we notice here that there is a horizontal line that has been graphed. So that means you are going to write y equals, and you're going to find where does that line cross the y-axis. And you can see that that happens at -5. So you should be typing in this equation right here. Y equals tells me it's a horizontal line. If there's no x in the problem, that is a horizontal line. And -5 is where it crosses the y-axis. Okay, can we convert from different forms? This is in standard form. We have x and y and their coefficients on one side, and we have a constant on the other. Can we turn that into slope-intercept form? Of course. All we have to do is get y by itself. So use your solving strategies to isolate y. First, move the x over. That has nothing to do with y. And then divide everything by the coefficient of y so that you have a 1y here. So I end up with y equals, you need to reduce the fractions to their lowest form. The negatives cancel out, and 9 over 6 reduces to 3 over 2. And negative 42 over negative 6 reduces to a positive 7. And that is my slope-intercept form. Okay, now if we look at the back, what if we're given a point and a slope? Well, if it was a normal slope, we would just put this in as x and y and the slope in as m and get the equation of the line using point slope or using slope intercept to find the y-intercept. But we've been given a special slope here, undefined slopes. Well, that's not a typical line. That's a special case line. That's a vertical line. So I know that my equation is going to start with x equals, and if I'm given a point, I'm looking at that x coordinate in a vertical line situation, and that is the number that I know the graph would be crossing the x-axis, that vertical line's graph. Okay, so a vertical line, you're always going to use the x-coordinate of the given point. If it had been a zero slope, a horizontal line, you would be writing y equals, and you'd be using the y-coordinate of the point that you were given. All right, can you interpret a situation that is linear, meaning it has a constant rate of change either being added or subtracted? Can you fill out a table and do whatever it asks you to do? It says Serenity needs to lease out a music studio to record her album. The studio charges an initial studio use fee of $400. That would be your starting amount. That would be your y-intercept. So I know that without using it at all, just to get to the studio and have a reservation costs $400 plus an hourly fee of $150. So every time the hours go up by 1, I need to add $150 to the previous amount. So that's going to get me these values, and they're going to ask you to fill that out. So make a table of values and then write an equation for P in terms of T. So T is time, they tell us. P is the price. And we're going to write an equation that uses these. So we have found everything that we need. We just need to put it in slope-intercept form. Now, instead of using x and y, we're using t and capital P. That's easy. We're going to use what normally is the y-coordinate, and then we're going to put the slope in, followed by the x-coordinate, or in this case, the t, and plus the y-intercept. And this is our equation. This is what you would be typing in if they had asked you to fill this out and then type in the equation. Make sure to use the letters that they give you, the variables that they give you. It's not always going to be x and y. All right, answering a context question from a table. So what if you're given a table and you can see that it's a linear situation with a constant rate of change? Serenity accepted a new job at a company guaranteeing annual raises. S is her salary after working for N number of years. So this is like our x and this is like our y. This shows the linear relationship between N and S. So they tell you it's linear, then you get to use a linear equation to help you. Determine Serenity's salary when hired. So they want to know what was her starting pay. So we can do this a couple of different ways. I like to find the slope and then find the y-intercept, which actually is the answer to the question that they're asking for. So I can use any 2 points to find the slope. And that is the answer in this particular problem, is when we put that slope in to a equation and solve for B, the y-intercept. So I'm just going to take these 2 points and I'm going to say, okay, what's the difference between 104,000 and 110,000? Well, it went up by 6,000. And what's the difference between year 3 and year 5? 2 years have passed. So our slope is that she made 6,000 more in a 2-year period, which means every year she was getting a $3,000 raise. So that is our slope. So if we were to now find the y-intercept, I could take this slope and any one of these 3 points. I'm going to take the first one and I'm going to put it into slope-intercept form and solve for B. So On year 3, when she was making $104,000, it was because she had had $3,000 added for 3 years from her starting amount, which we don't know yet. But if I were to put this, do the problem solving here, 3 times 3,000 would be 9,000. I need to subtract 9,000 away from her year 3 salary, and that's going to tell us what she made in her starting year, and that would be $95,000. Don't use commas. It'll confuse Delta Math. So just, if they didn't use commas here, you don't need to use commas here. And we answered that question. All right, we're ready to move on to the next one. So now we're on our last page. Really, truly almost done. This is a shorter unit today. They give us a graph, not a table, but a graph. And they say, Evan is using a computer at an internet cafe. The cafe charges an initial fee to use the computer. That's always your y-intercept. So they must charge $4 to sit down at that computer, and then an additional price per minute of usage. Let C be the total cost, that would be y, and let T be the total number of minutes that he's using the internet cafe. So we want to find an equation for this. Instead of x and y, we're using t and c. And then we're going to talk about the slope and what it means. They've given us 2 points. They've also given us a starting amount. I could use any 2 of these 3 points. I'm going to use these 2. So this is 5, 4.5, and this is 10, 5. And so what I need to do is calculate the slope. How much did the price change from using it for 5 minutes to using it for 10 minutes? Well, I can tell by the fact that 4.5 slowly crept up to 5. So it went up by $0.50 in a period of 5 minutes. So if we were to use the slope formula or rise over run, however you want, we would see a difference of 0.5 for the rise or the change in the y's, and we'd see a 5-minute difference in the times. And if we were to put this into our calculator, we would get 1/10, which is also 0.1 or 0.10, however you want to write it. So that is our slope, and our y-intercept we already can see on this graph is 4. So our equation, normally it would be y equals mx plus b, but because we're using capital C, here's our slope, 0.1. You also could have written it as 1/10. Instead of using x, I'm using t, and started with $4 just to show up. The slope of the function is 0.1 or 0.10, which represents the price per minute. In this case, it's 10 cents per minute. I don't remember which one of those is the right answer, but only one of those is on your list of choices when you click that. It's good to be able to interpret slope and know what that means in a real life situation. And then the last thing that we want to do is practice graphing linear inequalities. So when you are given an inequality like this to graph, and hopefully y is by itself already, if it's not, you've got to get it there. But once y is by itself, it clearly tells you a slope and a y-intercept. So I would plot the y-intercept. This graph was not already given to us, so you would put a dot at 4, and then you would use the slope of, in this case, it's 1 over 1, to plot a second point. So I think that's what I did here. I plotted at 4 the y-intercept, and then I went up 1 over 1, and I plotted this point. Once you plot 2 points, you will have a line that will be created. You need to know whether that line needs to be solid or dashed. So you have a choice of solid or dashed. Now, I believe the default is when you click your second point, it automatically turns solid. You need to decide, do I want to keep it a solid or do I want to change it to a dash? So I'm going to remind you, I think I've done this on another day assignment, but I'm going to remind you of the little organizer that reminds you of what goes with what. When you have less than or greater than without the equal to, you have a dashed line. So if you look at this is a less than, so I want a dashed line. So I really want this to be dashed. If you click this button, it will change it to the other type, and it will change it to be dashed. So do you want that dashed? Should be dashed. And then we also need to decide what direction for the shading to go. Let me remind you of the other organizer. You have a solid mouth. If they have either of those types of inequality signs, it will be a solid line. Okay, and so if we look at this, it is a less than. Let me just remind you that line will appear after the second point is plotted. Make sure if it's either of these, it should be dashed. If it's either of these, it should be solid. And then if it's anything with a less than, either of these that's a less than, make sure the shading is below, shade below, which would be underneath the line. If it's a greater than, either of the greater thans, this one or this one, we're going to shade above. And that would show up here. So change shade. When you click on that button, it's going to put the shading in one of those two places. Make sure it's in the right place. If it's not, click it again. It'll move it to the right place. This particular one, because it is a less than, it should be dashed and shading below. So we should see something that looks dashed, and we should see something where all the shading is underneath that line. And that is it. We are done for the day. See you next week.